Hello and welcome back to Sheaf Math. In today's lesson, we're going to be comparing linear functions, and those functions are going to be in the form of tables, graphs, and equations. Now, what exactly are we comparing in this video? We're going to first look at graphs, and then we're going to look at an XY table, and then an equation. And questions that you might get would be something like, if you look at the graph and the table, which one has the higher slope? Which one has the lower y-intercept? If x equals 3, which one has the higher y value? And so you're going to be asked to compare these different three. So the best way to learn how to compare them is to be able to find the important information about these three. So there's three pieces of information that are crucial for comparing linear functions. The first one is the slope, right? The rise over the run, the rate of change. The y-intercept, where that line goes through the y-axis, or the zero term. And also f of x. This is what you're going to also be asked to find sometimes. And f of x is simply, if x equals 3, what does y equal, right? The function of x. All right, let's look at graphs first, okay? And when we're trying to find those three key pieces of information, the easiest one to start with, I think, is the y-intercept. Wherever that line is going through the y-axis, that's the y-intercept. And ours, if you look, happens to be going through 1. And so our y-intercept is 1, or in the point form, you would put 0, 1. Now the slope. In order to find the slope, you have to find two really good points on your line. You have to make sure both of the points are going through really nice crosshairs, or lattice points as we call them. And so looking at this one, I can see that the line is for sure going through 4, 6 as well. So with these 2 points, 0, 1 and 4, 6, I'm going to find the rise and the run. Is it going up or down and then over to the right? So this one is going up by 5 and over 4. And so it doesn't matter which points you pick, it's always going to go up 5 over 4. And so 5 over 4 is our slope. Sometimes your slopes come out to whole numbers, sometimes fractions. That's okay. Now the last thing you might be able to find out is f of x. And so that would be something like this. What is f of 4? In other words, if x equals 4, what does y equal? So let's find 4 on the x-axis. There it is right there in green. And let's go up to see where the 4 and the line meet. And it meets right there. And so the y would be 6. So f of 4 equals 6. Okay? And so finding these three pieces of information on a graph is pretty easy. You just have to look at it, find the rise and the run, and then just kind of find the points that are necessary. Now let's look at a table. Now this particular table is a very easy table. And there are a few reasons why. And I put an easy one in here just to give you an idea of what we're looking for. So the first thing we're finding is the y-intercept. And the y-intercept, that initial value, is the 0 term. So when x is 0, that is the y-intercept. So our y happens to be 2. And so you could say the y-intercept is 2 or the point 0, 2. Really easy to find out if you have that 0 term there. Now let's find the slope. Now the first thing we have to look at is, what are the x's going by on the left? And you can see they're going up by 1. This is the perfect situation for us, because whatever the y's are going up by, that is going to be our slope. And they happen to be going up by 3 each time. And 3 is our rise, 1 is our run. And so 3 over 1 equals 3. Now sometimes you'll be asked to find f of x. So let's see, f of 4 right here. Well, we don't have 4 on our table, but it's close enough to where we can kind of just put a 4 right below there. And we know it's going up by 3, so 11 plus 3 is 14. So when f when x is 4, the y equals 14. So this is a very easy table. We're going to talk about how tables can get a little bit confusing a little bit later. So let's go on to the next one. Equations. So you have this equation in slope-intercept form, and these are actually the easiest to find the three key pieces of information. Who would have thought that the equation would be the easiest way? Now, we'll find the slope first, and if you remember, this is in slope-intercept form. And so the m is the slope. So whatever number is in that position, the coefficient of x, that is our slope. So our slope happens to be 3. Now we're going to find the y-intercept. And as you know, the b is the y-intercept. So whichever number is in the b position, in this case it's -2, that is our y-intercept. It's -2. Now, what if we were asked to find the function of, or the f of x? So let's say we were asked to do f of 4. So we simply, if x equals 4, we're going to put 4 in for x. We're going to substitute it in there and just simplify. 12 minus 2 is 10, and we found our y. If x equals 4, y equals 10. So again, the equations, when they're in slope-intercept form, are pretty easy to find those three pieces of information. Now I'm going to give you a reality check. On the problems that are often given on computer programs, the tables are not that nice. If you look at the x's here, if we wanted to find the slope here, look at what's happening to the x's. It goes from 1 to 3, that's up by 2, or over 2. Then it goes up 4. Then it goes up by 5. That's a real problem. Remember the table we had before, they went up by 1s. So let's look at what's happening on the y side. It's going up by 4, going up by 8, and going up by 10. Now, how in the world are you going to find the slope here? Well, I'm going to let you in on a little secret. I want you to look at the 4 and the 2 on the first two pairs. Okay? 4 is the rise, and 2 is the run. Okay? So, rise over run, 4 over 2, is our slope. Let's look at the next one, 8 and 4. 8 over 4 is our slope. And 10 over 5 is our slope as well. Now, these are different, aren't they? But they're really not. They're the same. 4 divided by 2, 8 divided by 4, and 10 divided by 5 are all 2. So this is a real easy way, and you really don't need to do all three of them. You just have to do the first two. If it truly is a function, it's going to have the same slope no matter how many times you do that. So that's a little secret I'm letting you in on. So now let's take a look at the the y-intercept. We know that our slope is 2, but we don't have a 0 term. And so I'm going to have you guys try something. I want you to make a new xy table, but this time I want you to have all the x's go from 0, 1, 2, 3, 4, 5, 6, 7. Now, why did I do that? Well, because when they're going up by 1, it makes it a lot easier to understand. And so if you see, I filled in the 1, 5 and the 3, 9 and the 7, 17. I didn't even bother to put in the 9, 21 because you really don't need it. All you really need is 2 points to make this. And so because we know our slope is 2, if I start at 5, it's going to be going up by 2 each time. So it goes up by 2 to 7, then to 9, then 11, then 13, 15, and finally 17. And to find the 0 term, well, you go backwards, you subtract 2, and that's 3. So it was a long way to find our y-intercept of 3. You could have done it a lot quicker by making the xy table smaller, but I want you to try this if you're just not understanding it. Make a new xy table with all of the values going up by 1 on the x. All right, there you have it. Now, you're going to be getting different questions that are asking you compare this equation to this graph, or compare the table to the equation. And they're going to ask you, about the slope, the y-intercept, and possibly the function of x, f of x. If x equals yada, 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 what does y equal? So with that information that you just got, finding all three of those pieces of information, you're going to be able to compare linear functions. Well, I hope this helped. Thank you for watching, and we'll see you next time.